Hello guys, another very interesting moving part in our application is actually API gateway, and we are gonna use the Ocelot as its implementation. So let me look at the big picture first. Ocelot is aimed at people using .NET running a microservice, service-oriented architecture, exactly as, that needs an unified point of entry into their system. That's wonderful. So in particular, I want easy integration with identity server. This is our toughest nut to crack. Reference and barrier tokens. So it's created actually to protect many APIs in one central point, and not only protect it, plays many roles. I'm gonna show you just in a minute another tutorial which actually explains this in pictures very well. Ocelot is a bunch of middlewares, which means that we just have to go to the startup, or even we don't need a startup. In the program file we will put everything in a specific order. That's it. Middleware in a specific order. Ocelot manipulates the HTTP request object into a state specified by its configuration until it reaches a request build middleware where it creates the HTTP request message object, which is used to make a request to a downstream service. Very complicated way to say simple things, but whatever. So you receive something from the web, from the browsers of the clients, and after that you translate this to the suitable service. You call the suitable service, and after that you respond to the browser of the client. So instead of the browser of the client directly accessing the services, what happens is you go to the API gateway, and API gateway knows which service to call actually to answer the request of the browser. That's it. Okay, so the middleware that makes the request is the last thing in the Ocelot pipeline. It does not call the next middleware. There is a piece of middleware that maps the HTTP response messages onto the HTTP request object, and that is returned to the client. That is basically it, with a bunch of other features. And it's very simple. The following are configurations that you use when deploy Ocelot. So you have different configurations and use cases. Basic implementation. This is the basic implementation. Clients, for example, websites, iOS application, etc. Public internet. Diagram showing Ocelot single server calling multiple downstream HTTP servers. So this part is called downstream. As you can see, it could be a private network. Configuration. With identity server, look at this, with identity server. So identity server, you get a token from the identity server. Here we go. And you determine, is this user allowed actually to access this or this service? And if it is, then you reroute, actually, no reroute, but you make the call, you get the message, you send it back to the client with the identity server. Private network diagram showing Ocelot single server calling multiple downstream HTTP services with identity server. This is exactly what we have. Here Ocelot has a reroute to get a token from identity server. Then we use the token for subsequent authenticated request to Ocelot. Finally, we proxy those requests unauthenticated to the downstream services, adding any claims information to the downstream requests. So those are a lot of use cases, multiple instances. As you can see, you can have many Ocelot servers with console. I don't even want to read that. With service fabric. Service fabric is Acer service. This is on Acer. So that's it. Let me show you another tutorial where the guy actually builds an Ocelot which stays in front of two clients, two APIs. So here we go, Ocelot, and you have two clients. two services, actually, not clients. Here we go, the clients. This is the browser. So instead of our browser accessing the services directly, the communication happens this way. I'm sorry I deleted, but I'm gonna draw it again. So browser communicates with the Ocelot, Ocelot to the service, and here the authentication and authorization happens on the Ocelot, which is a one central point. But look at here, the most important thing here is the benefits of the Ocelot. What is the API gateway? Gateway or gate is a point of entry that you have to go through if you want to access somewhere is protected. Okay, that's a good example right now with the Buckingham Palace. Let's imagine you want to visit Buckingham Palace, a famous place in London. Firstly, you will have to buy a ticket and then go through the toll gate gateway. At the toll gate, the checker will check your ticket. If it's valid, then you can access. If not, you should come back or have to buy a valid ticket. No, obviously you can bypass the toll gate, but you will be arrested if they caught you. Don't do that. Okay, you gotta go through the gateway. That's the main thing. Okay, similarly, API gateway is component that sits in front of your APIs and insides an internet or firewall. Implementing API gateway will help you to make sure that every request from outside internet will have to go through before reach your APIs. Note, we can have several API gateways in one application. For instance, API gateway for mobile applications and API gateway for desktop apps. Microservices, microservice everywhere. Wow, our dream. Why API gateway? Okay, now, over the past few years, applying microservices architecture instead of monolithic in software design has become very popular. Go along with this API gateway has also become one of key components. For example, a microservice-based application may have from 10 to 100 microservices. API gateway can help to provide a unified entry point for all external consumers that don't care about the number of microservices as well as their composition. Look at this. This is without the API gateway. So through the firewall goes the mobile application and the web application, and after that each one of them reaches the separate services on its own actually. But if you put the API gateway, you can have a desktop gateway and you have a mobile gateway. So the mobile requests go to this gateway and the desktop requests go through this gateway. So the features, why we should use API. However, applying API gateway has both benefits and drawbacks. The biggest benefit of API gateway is that clients just have to talk to the gateway rather than calling to a specific API. It also simplifies client codes. The API gateway also becomes development bottleneck because developers have to update the API gateway if want to expose their APIs to external. That is why the process for updating API gateway should be as lightweight as possible, exactly as we have it in the Ocelot. If not, the developer will have to wait in line in order to update API gateway. Because the API gateway is only one for all the team, it should be easy actually to add APIs. Which features then API gateway should cover? From my point of view, an API gateway has to cover at least the following items. Routing. This is one of the key functions of the API gateway. Basically, when API gateway receives a request from external, it will forward the request to the correspondence internal API based on a routing map. This feature is identical to reverse proxy feature provided by web server like Nginx. So it plays the role of the reverse proxy. API composition. An API gateway not only acts like a reverse proxy, but also implements some API operations using API composition. For example, your application provides a reporting function. This function requires involving of three APIs: get products, get bill, and get inventory, that belong to three different services: product, payment, and inventory. So you have on the back end three services which the application of the client should access in order to answer one simple question. Instead of that, you can compose all these three services on the API gateway, and the client could make only one request to the API gateway and get all the information instead of going to the three services individually. Without API gateway, your front-end project will have to call 3 times to 3 APIs. Instead, we just need to implement an API gateway using API composition feature in order to expose only one endpoint to external reporting. It will help the front-end project to efficiently retrieve data by single API request. Caching. Cache responses in order to reduce requests to the services. The Ocelot can cache the data, so the next time when the client requires data, is not even gonna turn to the service, is gonna return the cached information. Logging feature is necessary for tracing and debugging. It could log all the requests. Integrate with identity provider. This is crucial for us. Instead of integrating with identity provider for authentication and authorization on each service, we can centralize this inside API gateway. So one central point for authentication and authorization. Our identity server is gonna communicate only with the API gateway, is not gonna issue tokens for each one of the services separately. Rate limit, limiting how many requests per second are allowed on specific clients, blah blah blah. So this tutorial, I'm not gonna finish this tutorial. Let's go back uh, to the tutorial of the Ocelot. So get started. It's extremely simple to build Ocelot. In fact, API gateway. Ocelot is designed to work with .NET Core only, and it's currently on .NET Core up 3.1. .NET Core 3.1. Install NuGet package. All we have to do is install NuGet package. So what I'm planning to do actually is, let me see here, Ocelot Basic. This is how I'm gonna call my application, and I'm gonna use again not Visual Studio Prime, I'm gonna use Visual Studio Code. In the trash I'm gonna say .NET. This time I will need
Can you make another new folder? You may want to do another folder for this
No,
one.
I'm not gonna do that, because right now I'm gonna run only one project. I'm gonna have only one project, and this project will be put directly into the folder. So I'm not gonna create a solution and inside I'm gonna create directly the project, because it's quite simple. You know,
I just want to avoid that, this program is created in your trash folder.
uh, what do you mean by that?
When you make .NET new, it's gonna create it in your trash folder directly, no?
Yes, it's gonna create it. No, I'm gonna say minus minus name, and I'm gonna name it, so it's gonna put it in the folder within the same name.
Okay.
So this is the trick. Or minus O, it's you're telling where to create the project. So you have two options. One of them is minus minus name, and you give the name of the project, so the project will be created into the folder with the given name, and is going to use the very same namespace. Or you first can create the folder, and after that use the option minus O and create the project into this folder, which is already created. This is the
Okay.
difference.
Yeah.
.NET New Web, I would say, if we are not sure, of course, we always can say help. I need the simplest possible web application called empty. So I'm gonna use an absolutely empty, because as I said, it's a bunch of middleware. I didn't say that, I read that. So I'm gonna say .NET New Web minus minus name, and I'm gonna give the name of Ocelot Basic. And now it's gonna create in the trash Ocelot Basic. This is what I hope, at least. So let's see. I'm anxious to see what's going on here. Come on. Okay, so I'm looking for Ocelot Basic. You saw that. Okay, so another way is to create first the folder, and after that, when you create a project, you say .NET new web minus O, and you mention the name of the folder, which is gonna be Ocelot, for example. So now you're not giving namespace, you're giving directly the folder where it should be created, but that's not such a big deal. Ocelot, and I'm gonna say code, boom, and we are gonna have it. Okay, so we have one empty web application. No, I don't care about that. Ocelot Basic. So let's keep reading. Now we gotta install Ocelot, and this is gonna happen on the console. Okay, yes, create that. I'm gonna go to the console and say .NET add package, and I'm gonna say Ocelot, right? I think this is what it is. .NET package Ocelot. So now I'm getting Ocelot, and that's it. If I wanna see that, I go to project and I'm gonna see Ocelot version 16.0.1. Okay, so all versions can be found here. I don't care about that. Configuration. The following is the very basic Ocelot JSON. So I gotta create a Ocelot JSON file. This can be done with Visual Studio, of course. Prime, I don't remember. Okay, so that's it. Ocelot Basic. So I'm gonna create in the root one file which is called Ocelot JSON file. In the Ocelot JSON file, you describe the routes, the downstream paths and the upstream paths. So what the clients are asking is the downstream. So if somebody types Ocelot blah 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 blah, where shall I go? And now I gotta see, very important is this thing. For the Docker containers, this is gonna be crucial. Configuration. The following is the very basic Ocelot JSON. It won't do anything, but should get Ocelot starting. Okay. If you want some, and I want some example that actually does something, use the following. Okay, this is what I'm gonna use. But first we have to think, of course. So now let me think. What we are doing here. Now, upstream, if somebody types localhost column 5001, first let me make sure where is running now. Ocelot Basic project environment blah 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 blah.
It's on 5001.
Okay, it's on 5001. So this is what I gotta change. Thank you very much. Because I'm gonna run it with Castro right now. So I'm gonna change it to 5001. And this is crucial. As you can see, the configuration here, it's very simple. You can leave the routes empty. So no downstream, no upstreams. You're not rerouting anything. You're not using it, in fact, as an API gateway. Actually, you haven't set up anything as an API gateway, but at least the Ocelot should be self-aware about where it is running, on what IP and what is the URL. This is crucial. The global configuration, because we will read this just in a second. So I'm gonna change it to 5001 because it's gonna run on 5001. Okay, now, and what happens here is this. Downstream, so if somebody types localhost 5001 forward slash to do forward slash 1, for example, which is the ID, redirect this to downstream path to do ID, to do's, and send the ID, where use HTTP protocol. And what is the host? JSON placeholder type code.com. Let's go there. This is a placeholder. It returns something. GitHub. Here we go. Look at this. Not this one. 5001. Yeah, here we go. Type code. JSON placeholder. JSON placeholder is a simple fake REST API for testing and prototyping. It's like an image placeholder. Image placeholder is another service which just gives you a image. And here we go. JSON placeholder type com is gonna return something. What is this? No, I don't care about that. So let me try that and see what happens. So this is absolutely independent project. It just gives us the URL where we can try try JSON, something to do, for example, to do, and I'm gonna say one. To do one. I'm not quite sure, but I typed something wrong, I believe. So JSON placeholder, JSON server, low, blah blah blah. Here we go. Should be like that. So this is what you get when you access directly the API, right? It's just a placeholder API, which is just using for testing. You get this, right?
Yeah, yeah.
Okay, now,
Just to make sure it's working.
yeah, our Ocelot is gonna do a request to this URL on port 443 and is gonna redirect if somebody types and tries to access Ocelot on localhost 5001 upstream. Here it is, the Ocelot. If somebody types localhost 5001, is gonna redirect. Actually, it's not gonna redirect. It's gonna turn to this URL and is gonna use to-dos IDs, and it's gonna match this ID to this ID. So it does actually quite a lot of work, but let's finish the rest of the thing. So now, once we understand what it's doing and we set up properly the URL for the Ocelot, let's read further. So the most important thing to note here is base URL. Ocelot needs to know the URL it is running under in order to do header find and replace, and for certain administration configurations. When setting this URL, it should be the external URL that clients will see Ocelot running on. For example, if you're running containers, Ocelot might run on the URL 123 blah blah blah, but has something like nginx in front of it responding on API mybusiness.com. In this case, Ocelot base URL should be blah blah. So this is gonna be another challenge, like identity server. If we run this into a container, then what is the base URL? This is the main question. Okay, we'll solve this. If you're using containers and require Ocelot to respond to clients on blah blah blah, then you can do this. However, if you're deploying multiple Ocelots, you will probably want to pass this on the command line in some kind of script. Hopefully, whatever schedule you're using can pass the IP. Okay, so we will see that. Okay, let's look at the program file now. As you can see, we don't even need a startup anymore. All we need is only one simple file, which is program, and that's it. Then in your program CS, you will want to have the following. The main things to note are at Ocelot service, use Ocelot, wait sets up all the Ocelot middleware. And look at this. All this is done into the program file, not in the startup. It's not necessary, which tells me that actually everything could be done in only one file. Reading the documentation of ASP.NET is crucial as well. So, and that's it. This concludes the tutorial actually. This is talking about the .NET Core 1. And this tutorial is for .NET Core 3.1. So all I have to do is change now the program here and replace it with what we have here from the tutorial. I'm gonna comment out this. So now let's take a look. Ocelot Basic, the very same namespace. Program, main, start. New web host builder, and now they are chaining. Use Kestrel. They say it's obligatory to run Kestrel. Oops, my battery is running low. So use content root directory, get current directory. Configure app configuration, hosting context config. Look at this. Ocelot JSON, which we prepared, is gonna read the JSON. After that, instead of having configure services into the startup, they just put it here to simplify things and make only one file instead of putting all this information into the startup. Otherwise, you can keep the standard file and into the startup add the Ocelot, configure logging, hosting context logging, add your logging. I'm not gonna do that. Use Internet Information Services integration, configure, and it says use Ocelot and wait. Let's run this and see how it works. So I'm gonna go here on the Ocelot and I'm gonna say .NET run. .NET run. Eventually it's gonna run on 5001. Yep, it runs on 5001. Here we're not gonna. Oops, sorry about that. I just stopped it by accident. So it runs on 5001. We're not gonna see anything if we go there. Localhost 5001, but this is not the purpose of this Ocelot. Now, if I go to the configuration and see what I have to ask Ocelot in order to turn to this downstream, then I'm gonna do to this one, and voila, we got the very same result as we do when we directly connect to the service, but we got it through the Ocelot, right? So
Yeah.
that's it. So I think it's fun. Let me.
Ain't with it, it's alright, cause me,
What
I'm
is that
gone.
now?
I see y'all.
Okay, I started something by mistake. Sorry about that. So here we go. The real service. It runs on JSON placeholder typecon blah 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 to do one, and I'm calling the very same service, but through my Ocelot. And I can say two, of course, is gonna get the very same information from here to user ID 2, and so on and so forth. So this concludes our tutorial about Ocelot. I think it's a fun project. It allows us to do a lot of things. We read about all these features which we are getting. We are getting reverse proxy, routing, API composition, caching, logging, integrating with identity provider, which is gonna allow us just to determine, shall we turn to the real API to get the results, or shall we ignore the user if he doesn't provide a token? Okay, thank you.